So this is a lesson on trig equations, a second one that we've covered. In fact, there's been a lot of ground covered in the last little while, just examples of trig equations. This one, however, is going to depart slightly from what was done in the more recent ones. The recent ones concentrated on special angles, 30, 45, 60, in all the four quadrants, and the expectations are that you get good at those. These questions, on the other hand, just these two examples I'm looking at right now, are going to be where we're doing rounding. And in this case, we're asked to round to the nearest 100th of a rad. We can tell it's rads, again, because of the domain is in radian measure. Now, I'm going to do these ones with my calculator in rad mode. And the choice is always there that you could stick to degrees and then convert afterwards. But I'm going to do it directly in rads, and I would recommend that you do as well. And once you get comfortable with it, you have to be careful, but I think you'll find that it's quicker and more accurate. So put your calculator in rad mode. If you're not already, so mode and then down to rads. And then let's take a look at these two questions. The first one, 3 tan theta plus 2 is equal to 0. When we do the algebra on it, the 2 goes over and then we divide by 3. So we end up with tan theta is equal to negative 2 over 3. And this is not a special angle. That is not a ratio we're familiar with at all. So it means we're going to have to use our calculators. And remember, you can always use your calculators. It's just that if it is a special angle, it's easier not to. Tan theta is negative, so that tells me that we are in quadrants 2 and 4. Tan is positive in 1, they're all positive in 1, and it's also positive in 3. So we have to be in the two other ones. And then we look for our reference angle. And because it's not a special angle, we will use our calculator. So all I do in rad mode is second tan. Second function always when you're looking for an angle, and then 2 divided by 3, close that bracket. The problem with rad mode for most people is that the values don't make sense to them. It's hard to recognize where they're at with it. And with decimalized answers even more so. When you have, radian measure of pi over 3, whatever like that, pi over 6, those you can recognize, but those are exact values, and your calculator does not do exact values. So if you stick to your calculator strictly, you're going to have to just go on faith that you're working it out properly. Now I'm getting second tan of this is equal to an angle of 0.588. Because the question was asking to the nearest 100th, that is 2 decimals, I'm keeping an extra decimal alive. You could also keep the answer on your calculator, but one extra decimal will always work. And now I do what I've always done, that is I'll draw this diagram, a little grid, in quadrant 4, and in quadrant 2, and I'll be aware that my reference angle in rads is 0.588 and 0.588 down below in quadrant 4. And all you have to do now is for both of those quadrants, so quadrant 2, in order to get our rotation angle, theta would be equal to pi, because pi is right there, minus 0.588. So either subtract 588 or simply go pi minus your answer on your calculator. Either way, you'll get an angle of 2.55 once you round to 2 decimal places. And then we do the same thing for quadrant 4, or a similar thing in quadrant 4. This is 2 pi, so we need to subtract. To get our angle theta, we go 2 pi minus 0.588. And that will give us theta is equal to 5.695. Now I'll round that directly. 5.695 is 5. The 9 would have to go up, and this would round to 5.70 rads. And then we've got it. So here's answer 1, here's answer 2. Now had you done that in degrees, it would have been fine. You would have had your calculator in degree mode. We would have got a reference angle in degrees, and then at the end we would convert it over to rads. Will work, but try doing it in rads all the way, and I think you'll find it works really nicely. Let's do one more question. This one is another quadratic, and quadratics are always more complicated, if only because the algebra is more complicated. And I will make a substitution. Let A be equal to sine theta. So this becomes 5a squared minus 9a minus 2 is equal to 0. Looks like it might be a bit of a problem to factor, but let's see what happens. We know that that first term must break into 5a, and a has no choice. And I believe that this would be 2 on the bottom, 1 on top, a minus 2, and then 5a plus 1 will work. You're not really tested much on your factoring in this course, and usually you don't even get ones that are this complicated. But on the other hand, it's not unreasonable to expect people in 30 pure to be able to factor quadratics with pretty much 100% accuracy. Now we set them equal to 0, and you've been here many times before. You'll get a is equal to negative 1 over 5, or a is equal to 2. We now have to get back to trigonometry. So this is going to tell us that sine of theta is equal to negative 1 over 5. Always do a quick look to see, do I know the answer to that one? Is that a special angle? In this case, the answer is definitely no. The other is sine theta equal to 2. And we've got a problem right away. Sine ratio cannot be greater than 1. Your calculator will tell you this too. If you went second sine 2, it would shut you down. So there is no solution resulting from that ratio. I will bring up a new screen and look at the next one, but sine theta equal to negative 1/5 is the only ratio that's going to produce an answer. Sine theta equal to negative 1/5. And as before, I'm going to go after this one strictly in radian measure. I note that sine is negative, and because it's negative, it's going to put us in two quadrants, and it would have to be the bottom two. Sine is negative in 3, sine is negative in 4. Our reference angle. Once again, we use our second function key. We are in radian mode. Second sine, 1 divided by 5, close that bracket, and I will also keep this to 3 decimals, so I have 1 extra decimal as a rounding term. So 0.201. As well, like I said, you could keep this on your calculator. In fact, I do have it on my calculator with many, many decimals. But the 1 extra for the round is going to be adequate. In 0.201, well, it is tough to know what that means exactly. So you can't use your sort of sense of geography to help you with these ones. You know, 0.201, it's not like a degree where you know pretty much where you would be, and you can tell if that's a reasonable solution. In quadrant 3, and I'll do that right below, in quadrant 3, in order to find our rotation angle, I've got to go pi, which is right there, plus 0.201. And that is going to give me 3.34 rads. And then my quadrant 4 solution, well, that's 2 pi. So theta is going to be equal to 2 pi take away 0.201. This is going to give us theta is equal to 6.08 rads if we take it to 2 decimals. And there we go. So that's how you tackle these, and the questions are getting quite complicated. There's really only one more thing we can add to them to make them worse, and we'll be getting to that in a week or so. So thank you for your time.